Okay, let's find the solution for 7x is congruent to 22 modulo 31. First of all, we need to check what is going to be the greatest common divisor of these two numbers. And 7 and 31, there is no common divisor, which means the greatest common divisor of them is 1. Therefore, we have a unique congruent solution for that. Now, the question is, what is going to be the inverse of 7 for modulo 31? That's another tricky part to handle. But simply, if you just multiply the integer starting 2 and check with this number and what is going to be the remainder of this number for modulo 31, and if that is 1, then that should be our inverse. So for example, if you multiply 2 at 7, then 14 for modulo 31 is 14, which is not 1, so 2 is not the inverse of 7. How about 2 and 3, then 21, then still is 21. How about 4? 28 is 28. How about 5 and 35? Then for modulo 31, the remainder should be 4. So it's not still 1. So if you're doing that way, intuitively, then how about 9? Then 9 is 63. 63 is 31 times 2 plus 1. So the remainder is 1. So finally found the 9 is one of the inverse of 7 for modulo 31. And one thing is clear, between 1 and 30, 9 is the only one having that property, right? After you multiply with 7, the remainder is 1 for modulo 31. Right? Okay, so that's why we found the inverse of 7. So if you multiply 9 on both sides, then we know this part is just simply changed to x, right? So all we need is what this number, or what is the residue of this number for modulo 31. Okay. Then it turns out 12. So the solution for this equation must be 12, or actually is a congruence plus for 12, right, for modulo 31.